Hello students, I hope everyone is fine. So under the topic of theory of equations, I came with one more concept called as relation between the roots and the coefficients of higher degree equations. So already you are familiar with this topic under the school level. So if you take a polynomial section in school level, you have quadratic polynomial as well as the cubic polynomial, where you have learned about the relation between the zeros and the coefficient. But here I have written a concept called as the roots and coefficients, since it is an equation. So if you take any quadratic equation ax square plus bx plus c equals to 0, since alpha comma beta are considered as two roots, since it is a quadratic equation, it has two roots. So if alpha comma beta are the roots, then what will be the relation between the roots and the coefficients? First of all, sum of roots. Sum of roots is given by alpha plus beta. So how do you calculate alpha plus beta sum of the roots? Minus x coefficient by x square coefficient. So what is x coefficient here? B. That means you will get minus b by a. So that means alpha plus beta is equals to minus b by a. Similarly, if you take alpha beta product of roots, so it is given by constant by x square coefficient. Here what is the constant? C by a. So this is called as product of roots. So you have sum of roots as well as the product of roots. It is given by alpha plus beta and alpha beta. Similarly, if you take a cubic equation, we have cubic equation ax cube plus bx square plus cx plus d equals to 0. We have alpha, beta, gamma, three roots. Why? Because it is a cubic equation. It contains three roots. Here also, if you take sum of roots, alpha plus beta plus gamma, it is given by minus b by a. But when you come to product, two categories are there. So what is that one? First one is product of roots taken two at a time. How is that? Alpha beta, beta gamma, gamma alpha. That is nothing but C by A. If you take just a product of roots individually, product of roots, alpha, beta, gamma, it is given by minus D by A. Similarly, if it is a biquadratic equation, so what is the degree of this one? How many roots it will be having? 4 roots. So what are those? Alpha, beta, gamma, delta. Suppose if I take sum of roots, alpha plus beta plus gamma plus delta is equals to minus b by a. Again, as we have seen the variations in the product of roots, here also product of roots taken two at a time. It is given by alpha beta, alpha gamma, alpha delta plus beta gamma plus beta delta plus gamma delta. So it is given by C by A. Similarly, this time product of roots taken 3 at a time. That means alpha, beta, gamma, gamma, delta, gamma, beta, gamma, delta, gamma, delta, alpha and delta, alpha, beta is equals to minus dy. Now just product of roots alpha, beta, gamma, delta. It is given by E by A. We can see the variation here, sign minus B by A, C by A, minus D by A, E by A. So this minus and plus is coming alternatively. Let us solve one example problem based on this concept. If alpha comma beta are the roots of ax square plus bx plus c equals to 0, then find the value of alpha by beta minus beta by alpha whole square. You can take this condition and solve within the bracket. What is it? Beta alpha, that is nothing but alpha beta I can write. So I can write it as alpha square minus beta square whole square. Don't forget the whole square. Now this can be also written as alpha plus beta into alpha minus beta within this bracket, alpha beta whole square. Now in order to solve this problem, I can replace alpha plus beta as minus b by a since the equation is given. Alpha beta with the c by a. But what about alpha minus beta? So we can connect this alpha minus beta with alpha plus beta and alpha beta value. How? By following the algebraic identities, alpha minus beta whole square can be written as alpha plus beta whole square minus 4 alpha beta. Now here alpha minus beta whole square is equals to alpha plus beta whole square nothing but minus b by a whole square, that is b square by a square. Now here 4c by a. Now LCM will be a square. Now you will get here b square minus 4ac. This is the value of alpha minus beta whole square. But I want only alpha minus beta value. So then I can write it as whole square root alpha minus beta is equals to square root of b square minus 4ac by a square under square root. Now take the same value and substitute in the given condition. What is that? Alpha plus beta minus b by a. This value square root of b square minus 4ac by a square by c by a. Here a gets cancelled, but don't forget the square. If you apply the square, this negative value will become positive, that is b square, and this square and root gets cancelled, you will get b square minus 4ac by a square will be as it is, and c also will get square. I will get this value. So this is the value of a given condition. So like this, you can use the concept of relation between the roots and the coefficients by applying the condition. Here we have one more example. If alpha plus beta is equals to minus 2 and alpha cube plus beta cube is equals to minus 56, find out the quadratic equation whose roots are alpha and beta. So we have to find out alpha and beta. So now he has given two conditions. What are those? Alpha plus beta is equals to minus 2, alpha cube plus beta cube is equals to minus 56. So can you connect these two? If you cube on both sides, you will get a alpha cube plus beta cube condition. So by taking this alpha plus beta is equals to minus 2, what I will do? I will cube on both sides. If I cube on both sides, I will get alpha plus beta whole cube is equals to minus 2 whole cube. Then by applying the algebraic identities, alpha cube plus beta cube plus 3 alpha beta into alpha plus beta is equals to minus 8. Now I can replace this value with minus 56 and this value with minus 2. So minus 56 plus 3 alpha beta minus 2 is equals to minus 8. So now minus 56 you transpose. So 3 to the 6 minus 8 plus 56 minus 6 alpha beta is equals to 48 and alpha beta is equals to 48 by minus 6 6168. So alpha beta we got it as minus 8. So here we have alpha plus beta and alpha beta. So no need of alpha beta individual values. So we know that whenever we know alpha and beta values are alpha plus beta and alpha beta, that is sum of roots and product of roots, the quadratic equation is given by this formula. So what is alpha plus beta here? Minus 2. So minus of minus plus 2. Alpha beta minus 8. So this is going to be the quadratic equation whose roots are alpha and beta and satisfying these two conditions. So here is an example. If omega is an imaginary number, omega, so you will get this concept in a complex number, so we are going to discuss that concept. So if omega is an imaginary cube root of unity, then the equation whose roots are 2 omega plus 3 omega square and 2 omega square and plus 3 omega. So these are the two roots. So if you go for, if you know that when two roots are given, what is the condition, how to find out the quadratic equation? So sum of roots and product of roots you have to find out. So if you go for sum of roots, so you have to add these two. So when you add these two, 2 omega plus 3 omega square plus 2 omega square plus 3 omega. So what is the value you are going to get? So you are going to get 2 plus 2, 2 plus 3, 2 plus 3, 5 omega, 3 plus 2, 5 omega square. Here 5 is common. Omega plus omega square. So what is the value of omega plus omega square? So we have in cube roots of unity concept in complex numbers, 1 plus omega square is equals to, it is not w, it is omega. So it is written just like w, but it is not w. So 1 plus omega square is equals to 0. That means if I want omega plus omega square value, I can write it as minus 1. So here 5 into minus 1, minus 5 is the value. Similarly, if you go for product of roots, so that means you have to multiply 2 omega plus 3 omega square, 2 omega square plus 3 omega. So 2 to the 4 omega cube, 2 3 the 6 omega square, 3 to the 6 omega power 4, 3 3 the 9 omega cube. So here 4 omega cube, 9 omega cube, we are going to get 13 omega cube plus 6 is common here, as well as omega square is common. So what is left then? 1 plus omega square. But what is 1 plus omega square from this condition? So you can write 1 plus omega square value as minus omega. So that means 13 omega cube plus 6 omega square minus omega. So plus into minus 6 omega. 13 minus 6, 7 omega cube. What is this omega cube value? Again, when you refer this complex numbers, omega cube value is written as 1, cube root of unity. Omega cube is equals to 1. 7 is the product of roots. So we know the sum of the roots, product of the roots. What is the formula? So x square minus half alpha plus beta into x plus alpha beta equals to 0. Here alpha is nothing but this condition value, this expression, and beta is nothing but this expression. So when you add them, I got minus 5. Minus of minus 5 plus 5 alpha beta 7. So it is the quadratic equation required.